Thank you very much. My name is Kjeld Svidt. I come from Aalborg University in Denmark, and I have been asked to tell you everything about BIM education in Denmark. That's not so easy, so I think I'll try to limit the scope a little bit. I'll first give a short introduction to my own background, where I come from. I'll try to address this topic in general about BIM education and in engineering and architecture educations in Denmark. Then I'll tell a little bit about relatively new education we started in Denmark a few years ago at Aalborg University. We call it building informatics. One of the previous speakers said that we should not invent a special BIM education. I'm sorry, we did something like that, but I think we see it a little broader than BIM. And finally, I'll tell a little bit about the Digital Days, which is an annual educational experiment we do with students from several different educations from different institutions. So, I come from Aalborg University. We are originally located. Can I point here? No, I can't point here. Here in the northern part of Denmark. But we also have a smaller department in Copenhagen, in the eastern, our capital, and a small department in Esbjerg in the very western part of Denmark. But the main campus is in Aalborg. And the other educations I'm going to talk about today are actually located all over Denmark. So we have architecture educations in Copenhagen, over here, and in Aarhus, here, and also at Aalborg University, up here. So we have architect educations in different places. We have engineering educations in several places in Denmark, like 8 different cities have engineering educations. We have construction architect educations also in 8-9 different locations. And all of these different educations all have some kind of BIM is relevant for all of them to some extent. So I'll come back to that. Just shortly, my own background. I'm in a small group we call Building Informatics in the Department of Civil Engineering at Aalborg University. We are a quite small group, but I think again BIM competences are positioned in different departments of our university. So, I don't know if we need to repeat, but I mean what we're dealing with when we're talking about BIM and information technology in construction industry is mainly these communication challenges. So we need to handle consistent information through the entire building process, from the initial ideas of building to the entire design process, handing over information to tendering and construction, and again handing over information for building owners, facility management, use and operation of the building. And for that purpose we need to be able to identify what kind of information I'm sorry, this is in Danish, but it illustrates that we have a number of different information containers in different formats. Like here, different information containers, information represented in different ways. It could be CAD drawings, object-based Revit files, Excel spreadsheets, Word documents, access databases, and so on. So we have many representations, and we have different needs, different actors in the entire process. And of course, again, when we say BIM, we look very much at digital building models, how we handle them, I think all the years we have been talking about BIM, we have had very much focus on the integration of CAD models and different analysis models. We would like to be able to just by a click of a button make any kind of analysis from the CAD model, structural analysis, energy analysis, cost analysis, scheduling, and so on. And we haven't reached that goal yet, so I think we will see further development the next 10 to 20 years in this area. So we have all these, this is only a design and construction process. We have a number of actors with each their own special model. Different people are creating different models of the same building, handling different aspects of the building. They need to be able to work in parallel, and we would like to make collision checking coordination between these, so there shouldn't be any collisions when we're going to build the building. And we of course have to decide how often do we want to put this in one big shared model if it was technically possible, and make collision check every second, so everybody got an alarm every time there was a collision? Or do we want to check every week, for example? Or, these processes, there's not one obvious answer, I think, on how integrated the model should be and how often we should make collision checking between the different models. So we have a lot of people integrated in design. We like to somehow collect these models in one model for collision checking and quantity takeoff and so on. And when it comes to procurement and construction, we split the models up in different tasks again for different contractors, subcontractors, suppliers, and so on. And when it comes to operation and maintenance, we have another view of the building. So we again need to extract information in a new way for this space. So we have many challenges to deal with. So this was setting the scene. Some of the projects we have been involved in recent years. I don't think I have time to go through all these, but we have been involved in different research projects regarding collaboration, both processes and technology development for the construction industry. Right now we have an ongoing PhD project on BIM and sustainability assessment. What we see today, we have in different countries, we have a number of sustainability assessment schemes, so you could get your building certified when you have designed it. And what we see is that this knowledge built into these certification schemes is actually difficult to bring into use in designing the building, in the early design of the building. So this project is looking at how can we bring this knowledge in use in the very early design phase for the people who are actually building the models. Yes, and now to the main topic. I was going to tell about BIM in education in Denmark. As I mentioned, we have a lot of different educations in Denmark where BIM is relevant, and we actually have a network in Denmark of the BIM researchers and teachers. We call it this BVU net. And it was established a few years ago, and we actually have regular meetings where we discuss, share experiences, and discuss strategies for BIM education, and also try to discuss who delivers what kind of information for which kind of students. So it's a very good network between engineering schools, architect schools, and university colleges who educate the constructing architects. And we made a survey a couple of years ago where we tried to look at all these different kind of schools and where could we identify courses and educations where BIM was relevant, and we tried to list all courses and content and what kind of tools we were using in these courses. So I'm not going to go through every detail of this, but I have extracted some information from some of the different schools here. And I only look here at architecture and engineering educations. So one of the schools in architecture is the Copenhagen School of Architecture. We identified 3 main areas they focus on. They have some courses focused on design collaboration and BIM. They have courses focusing on the combination of digital modeling and energy analysis. They have another course focusing on the design process and referring to the governmental requirements, and they use for that they use Revit as a specific tool. If we go to another architect school, Aarhus School of Architecture in the western part of Denmark, they also identified a number of course education initiatives within this area. They have something they call abstract modeling, where they use SketchUp, Rhino, Grasshopper, different software. They have a course called Digital Production, where they use Rhino, AutoCAD, and a laser cutter to produce physical models from their digital designs. They have courses in parametric modeling and design. Again, these tools are maybe typical for the architect schools. They are more focused on what you call it, the form of the building, and not so much the actual building components. So it's Rhino again, Grasshopper, Kangaroo. They have courses architectural modeling in Revit using Solibri Model Checker, and they have something with BIM and simulation. Again, the connection between the CAD modeling and energy analysis, Ecotect, and BE10. The last term is a Danish software to check to what extent the building meets the Danish energy requirements. In Aalborg University, my own university, we also have an architectural education. We identified they have these 3 different areas. They introduced the object-based 3D modeling with AutoCAD and Revit. They have courses again in parametric design, like the other architect schools, Rhino and Grasshopper. And they also teach the students about structural analysis using Autodesk Robot. Now, turning to engineering educations, we have the Danish Technical University in Copenhagen. They have quite many courses focusing on this area. Building information modeling with Revit, Solibri. Sigma estimation is a Danish software for price calculation. FemDesign is a Swedish software for find element analysis. They have courses, general course BIM for building design. They have something with digital building models, SketchUp and Revit. They have something with focusing on visualization, going to 3D Studio and Photoshop, combination with CAD tools. And they also have courses together with the construction management department, where they focus on using the BIM in construction management processes. When it comes to Aarhus University, also in still engineering educations, they have chosen to use ArchiCAD, where in Denmark we see very many schools using Revit. This school has chosen ArchiCAD as the first BIM modeling tool the students learn. They use a lot of other software for drawing or a course to show the combinations of the modeling and estimation, energy calculation, scheduling, and so on. And they also have a focus on the structural analysis part. In Aalborg University, we also have a number of courses We teach our students in the beginning a basic CAD where they learn about different ways of handling representation of a model, basic geometry like lines and circles and so on, and faces, volumes, and turning to BIM, we have building objects like walls, doors, windows, and so on. Later on in the study, we have a course called IT-supported collaboration and digital models, where we learn them Revit, we learn them Solibri, Model Checker. We have some add-ons for the CAD systems, some productivity tools. We learn them fine element design also. We learn them Lumion visualization software, and we also learn them a little bit about the basics. I mean, behind all these models, there's some kind of relational database. So we give them a short tutorial in Microsoft Access to give them a basic understanding of that kind of information management. We have a course more focusing on IT for infrastructure and modeling in that area. We have a course for those who take our construction management education. We have a course together with some other educations where it's a book called BIM Handbook by Chuck Eastman, which is the basic book in this course, and then we take in different examples of software during the course. They also learn. We also have some courses where we focus on the integrated design of buildings and building services. That was architects and engineering educations, very short. And now we come to, what we see in all these educations is maybe a main focus on learning our students tools and a little bit about processes, and nothing about how to develop software, how to implement new systems in the industry, and how to make sure we have the right competences. What problems will there be? Organizational, people's traditions, any kind of resistance to implement new systems. So we actually started this new education a few years ago. We call it Building Informatics, where we try to look at ICT support for the construction industry, business processes. We learn these students to tools, methods to analyze the business needs in the construction processes and analyze and describe the information flows between all the different actors. And of course, we learn them how to manage this information in 3D models, drawings, documents, databases, and so on. We learn them about national and international standards in the area. It could be a national classification system. It could be the Building Smart standards for IFC and information delivery manuals and so on. And the intention with this education is that these students should, or these candidates should fill the gap between software developers and system suppliers, CAD system suppliers, and the end users in all aspects of the construction industry. And a short extract of some of the courses or projects we are working with during this education. In their first semester, they have a project where they look at ICT in design and construction. It's a problem-based study where they always have an actual ongoing construction case, preferably in the local area, so we can go and visit a construction site and see how information is managed here. Then we have the same course as I mentioned earlier for some of our engineers, where we use this BIM handbook. So general course in BIM in constructions. We have something about more theoretical about virtual buildings and BIM data models behind all these models. That would be IFC, the international standard, and so on. We learn them about information delivery manuals, how do we identify needs and describe requirements for information deliveries between different actors in the industry. We also cover a little broader than BIM, so we focus on knowledge management in general. BIM is a part of knowledge management, you could say, or a tool you could use in knowledge management in the industry. We focus a little bit about collaboration, and we also learn these students something about how to make requirements to the software, usability requirements for software. There are different requirements if you use the software in your office or at the construction site or in different situations, if it's mobile devices or it's a big virtual reality center and so on. So we have very different ways of interacting with the models, which gives different requirements to the software. Yes, and we also give them a short course, actually just a kind of programming course. They learn to very little programming, because I think computer scientists can do the programming, but these people need to have a little bit of knowledge about this area. Yes, I have a long list of recent projects. We don't have time to go through this, but examples of master thesis projects that have been done in this area, focusing on early phases, late phases, problems more related to organization than technology, and some problems more related to technology than the people, and so on. So we in different projects we cover many different aspects of the use of IT in construction. Finally, one course or activity we involve these students in, together with a lot of other students, is this we call the Digital Days. This year, it was held last week actually. We finished last Friday, 1 week ago. We collected this year 80 students from 8 different educations, from 3 different educational institutions. So that means it's engineers, architects, construction architects, craftsmen, and we give them a task to actually, as I say here in the bottom, go from 0 to tender documents in 3 days. It's challenging, but they actually get quite a long way in this. So we give them some initial Revit model. So they have some. This was a renovation case, and they have some. A description of the existing system, and then they have some requirements. This was changing an old industry building to office building, and there was some requirements about getting more light in the rooms and meeting energy requirements and so on. And all these different student specialists, they managed in quite a good way and a very creative way to come up with good suggestions within this very short time. So it could look like this. There are many students active in the same time, and we always see that we bring them in situations where they really feel that we have serious problems and they have to solve them somehow, and there's nobody to help them. They need to solve it themselves. And they have coordination meetings and together they cover several BIM aspects. They meet the problems in collaboration between the different actors. They meet students they have never met before. They must collaborate during these 3 days. And they use all different kinds of software, and they actually come up with very interesting results at the end. So, thank you.
So, could you please tell us a little bit more about how the specialists that are already in the labor market, who are already working, how are they being trained? Is there a system in Denmark for that?
Yeah, I mean, these people we have educated,
the persons who are already working, because not the students.
How do we upgrade people?
Yes.
There have been a number of attempts, and we have a number of private companies who offer courses. I mean, it could be shorter or longer courses. We have like 3-day courses you can attend to give a very short brush up on what is this BIM and so on. We have some others have given like a 10-day course, 10 full days distributed over 3 months or something like that. So you come in 2 days, go back to your work for a couple of weeks, come in 2 days again, and so on. So we have different ways, different levels of upgrading people. We actually, in this group we have with the universities, so we often discuss if we could make this kind of educational offers from the universities. We had something a little bit close to this many years ago, which we actually stopped again because there were too few customers, but it may be a new situation now. So, and I think it's difficult how we should manage this actually. Also because at the universities it's a very different kind of education you need to give for professionals who have short time for this and for the students who we have for 2 years or 5 years. But there are some possibilities in Denmark for upgrading your competences in this area.
Thank you very much.
Maybe it's not a question, just a little note, because I myself just finished Aalborg University in Copenhagen, and they have a master's program actually. It's called Management and Informatics in Construction, and it doesn't concern software so much, because as I understood in Aalborg they more concentrate on software solutions, but this new line, I just wonder, you didn't mention it. It concentrates more on the strategy and classification and standards, and it doesn't do anything with the software, which is more on the management level, which I think is very, very good part of it. I'm just wondering, you didn't mention.
Yeah, so if I understand you correctly, we have an education that should focus on the technology, but does not. I think we have a challenge also in our ordinary educations, because all the courses I have mentioned today here is like given. We have a problem that it's given by specialists, and my closest colleagues. Either they don't care or they don't have time to be interested in this area, because they have to focus on energy analysis or structural analysis and be very highly specialized in these different areas. It would be the same in construction management. That we say, okay, the students, they can take a video tutorial of the software. We don't need to teach them that, so we give them the basic theory. So I think in general it's difficult. How do we get this as a natural element of all parts of our education? And especially, I think especially at Master of Science level, it's difficult to spend time on teaching students just some software because we want to give them theoretical backgrounds.